Our next topic is Poisson's ratio. What is Poisson's ratio? But before that, we should know what is longitudinal strain and what is lateral strain, right? Suppose we have a bar, say it is a circular bar, and we have applied some force to this bar, P. There is some elongation in this bar in linear direction or in longitudinal direction, right? This is the original length L, and there is some deformation in this bar, delta L. But as there is elongation in linear direction, there will be some decrease in dimensions in transverse direction or in lateral direction, right? So you will find that actual shape of this body will not be this, but there will be some deformation or decrease in dia. If it is circular, decrease in dia in lateral direction. So you will see this type of dimensions after the force is applied to this material. So this will be the actual condition. It means its dia will be reduced as the length is increased, because the volume has same, the volume of the material is same, there is no change in volume of the material. So due to that, there is decrease in dia, and the initial dia was this D, and there is some change in dia, delta D, right? So delta D is the change in dia. So after deformation, say after deformation, the dia becomes D dash. So delta D will be equal to D minus D dash. Final dia, initial dia minus final dia. So there is some change in deformation, change in dia of the body, right? So now there is two types of strain in this material. There are two types of strain: linear strain and lateral strain. So we define lateral strain as change in length in lateral direction, change in length in lateral direction per unit original length in lateral direction, original length in lateral direction. So this is the lateral strain of this material, right? So here lateral strain epsilon dash will be equal to change in length in lateral direction. Change in length is delta D because it is dia. So delta D upon the original dia of the body. This is the lateral strain. And what is linear strain? Linear strain, as usual, we are using it along back, that the change in length upon original length. So this is the linear or longitudinal strain. Linear strain. So we have lateral strain and we have linear strain. Linear strain in which the force is applied that direction, and lateral strain perpendicular to the direction of the force applied. So lateral direction and linear direction. So we have obtained two strains. Poisson's ratio. What is Poisson's ratio? Poisson's ratio states that the ratio of lateral strain to linear strain will always remain constant, right? So ratio of lateral strain to linear strain will always be a constant for a given material. For a given material. It is a material property, right? Means epsilon dash upon epsilon should be equal to, and that ratio is called Poisson's ratio. And that ratio is called for a given material, and that ratio is called Poisson's ratio, right? So this ratio is called Poisson's ratio, and we are denoting it by mu. This is denoted by mu. Is it okay? So mu is the Poisson's ratio, epsilon dash upon epsilon. Now sometimes we use negative sign here. It is negative, but we do not use negative sign for this Poisson's ratio. It is always shown positive, but actually it is negative. How? Whenever there is increase in length in linear direction, there is decrease in length in lateral direction. So actually, if in actual practice, you can write mu as minus epsilon dash upon epsilon, and because the minus is obvious, but we skip in writing. In most of the cases we skip this negative sign because this negative sign is obvious, but in numerical or calculation we will use the negative sign to show that in lateral direction there is decrease in dimensions if there is increase in dimension linear direction, or the opposite or the case may be opposite. So this is the Poisson's ratio.